Okay. Good morning, everybody. I hope everyone can hear me. Welcome to Wednesday, I think. Wednesday? If it's 8:30, it must be Wednesday. Okay. I'm acting as conference chair, user meeting chair this morning. So the first thing I'd like to do is introduce John Daintree to you. He's been with Dyalog now for, I think, nearly 23 years, which means in 2 or 3 years he'll match John Scalzi's half of life deal. John's going to talk to us about data binding. Please excuse him, he sometimes gets a little bit grumpy and argumentative. So, John Daintree. Thank you, John. You're welcome, John. Right. Before we start this, I want to start, and we're going to tread some new ground. I'm going to try and achieve something that I have never achieved, and I want to try and achieve something with your help that, as far as I'm aware, has never been successfully achieved at any APL conference. We'll come back to the PowerPoint in a moment. Ah, no, wrong machine. Right, there. Right, hold on. What we're going to do, come to my desktop, come here, we're going to do this. Okay, we're going to do this. We're going to do this. We're going to do this. Right, we're going to do this. All right, everyone over there, smile. I've got to get in it. Okay, and then one more over here. Everyone smile. Am I in it? Right, okay, mission accomplished, APL selfies. It's all downhill from here, but at least that worked. Okay, so I'm going to talk about data binding. Now, I didn't come up with a title for this presentation, but fortunately it turns out quite well. There's a trilogy here, and we started off last year with data binding. This year, data binding reloaded. We're going to revisit some of the themes. You know, some things will be slightly reminiscent of things that maybe you've seen before. Next year, I promise you, it's data binding revolutions. Okay. You may see a parallel here. I thought I did. I can't tell you what that is. It's all copyrighted stuff. These pictures, it doesn't say Keanu Reeves up there. It doesn't say, I was going to say Samuel L. Jackson, but that's an old joke. That's the wrong fella anyway. So it turns out, of all places, I can't even do a gag about a matrix at an APL user meeting, conference, whatever it is. So what I'm going to talk about is I'm going to recap some of the stuff that we introduced last year. I'm going to show you some new uses of data binding, or at least uses that I didn't show last year. I'm not going to show you things that we can't do. That's quite difficult. But what I'm going to do is I'm going to show you things that maybe are a little bit tricky to do now, that maybe in 14.1 and 15 will make somewhat easier for you. But the whole process of data binding is essentially an idea where one can sort of extract your data a little bit from your user interface. When we use things like QuadWC and we have callbacks and stuff that manipulate the data, it's sometimes very difficult to separate the business logic, the stuff that's crunching the numbers, from then how you present that to the user. And data binding throughout sort of gives us a nice way of separating our data from our user interface when we're conceptualizing our application and when we're writing our code. Data binding is used tremendously throughout the WPF Windows presentation framework. You can do all of this stuff without data binding, but all of the samples that it's a bit circular, all of the samples I've been looking at while I've been researching data binding have been using data binding. But I mean, it's such an easy and nice way of getting your data into a WPF application that it is pretty prevalent in that arena. I think it was Brian Becker yesterday who showed an example of how one might create a WPF GUI element in code, and this is how it looks. It's got, where's the thing? You know, we create new windows and we create things called stack panels and we create things called test boxes and list boxes and those sorts of things, the names of which you are familiar with. And that, if we were to run that code, that would generate a user interface that looks exactly like that one. But something else that we can do to define our user interface layouts in WPF is we can use this markup language called XAML, which is very much like XML, but there's support throughout the .NET framework in WPF to read this XML XAML text and instantiate objects from it. And here is the XAML that would have been used to create the very same user interface that we saw on the earlier slide. And what we would do is we would basically throw this text at various .NET-y things, and out at the end would pop an instance of a window that was populated with this stuff. And just to break this down a little bit, what we have here is we have a declaration of a window, which is the outer part of the container. And inside that, we have a stack panel, which is a user interface element that arranges its children and orders them and worries about their geometry on the screen. So inside our stack panel, we have the text box at the top, and then we have a wrap panel, which organizes its children horizontally. And inside the wrap panel, we have one list box and another list box. And as I say, the wrap panel arranges its children horizontally by default, and a stack panel arranges its children vertically. And by using these panel objects, then we don't need to worry about where these things are positioned. There's no code in here that says where something goes. There's stuff that says how big something should be, and there's stuff that says, you know, what gaps do we want between elements. But we actually then don't have to do the calculation about figuring out where everything goes, which is handy. Here's some more WPF. Those of you that haven't had the chance yet to see what's on my T-shirt, that is it. Turns out you can define pretty much anything in XAML. XAML, of course, though, is a lot easier than real life. Okay, can't do that as I'm stood here today. So let's talk a little bit about data binding and what and how it actually sort of is glued together. Typically, we'd have a user interface element, and in our API application, we'll have a workspace. And what we want to do is we want to associate with a text property, say, of the field at the top, a character array inside the workspace. And typically with data binding, this is a two-stage process. First of all, we need to create some sort of source, which is a .NET object that connects to that character array. And then once we have our source, we set up a thing called a binding that sort of glues together the text to the source and then ultimately to the character array. Now, with some objects, we don't need to create a binding. We can just attach a source directly to a property of the user interface element. And furthermore, we can create a data binding source to a namespace inside a workspace, and then we can have multiple bindings on that. And if we set this up like this, then we can have one namespace that can provide data to multiple user interface elements inside the form. And we'll see examples of this as we go through. So basically, we have this sort of picture. What we have to do is we have to create some sources and we have to create some bindings. The sources in Dyalog can be created actually in XAML. You could actually write that up in this static text to say where the data is going to come from. You could actually use just plain APL.NET calls through the bridge to create things that can be used as data sources. And actually, we'll see some examples of that. But what we introduced in version 14.0 was this 2015 IBeam, the data binding IBeam. And what that does is it allows you to provide some types of APL arrays as the right argument to the IBeam, and the interpreter will generate a source for you, and then we'll handle a lot of the plumbing to get the data into the user interface element. And then typically setting up the binding is done entirely in APL or in the XAML. There's not really a great deal there that the interpreter can help out with. But the end result of this is that we get a direct connection from stuff in the workspace to stuff that's in the user interface. And generally, code in the workspace doesn't care how this is laid out and what it looks like, and stuff over here doesn't really end up caring about what the workspace looks like. And again, in the namespace case, that can provide data to multiple user interface elements. Okay, so here's just some slides that are basically just going to very briefly introduce some code that we'll look at as we go into a demo later. But here's an example of a UI creation that just creates a window that contains a single list box, and we can specify that we want all of the items for the list box to come from the content of the variable called dialog names, which in the simple case is a vector of character vectors containing the items that we want to appear in the list box. If we wanted to set up some bindings for the more complicated example, this list box thing, here we create a namespace that contains three variables: filter, filtered list, and dialog names, again the names of, one might suppose, employees of Dyalog. We create a data source from using the 205 IBeam, but this time rather than giving it the name of a vector of character vectors, we give it the name of the namespace. And then we set up various bindings. We create a new binding object, which we then associate with the filtered list, which is the list on the right-hand side of the user interface, which will be then associated with the filtered list member of the namespace. We do the same thing with the list box that appears on the left. Tell it should get its content from the dialog names element of the namespace. And finally, we associate the text of the text field at the top with the variable called filter, which is inside the source as well. And a kind of cool thing that we can do here is we can specify that the binding for the edit field works in two directions. We change the variable in the workspace, then the content of the user interface changes. But the two-way says if we type into the edit field, then the content of the variable in the workspace automatically changes as well. But we do get some notification to say that something has changed, and we'll talk about that as we go through. Something else we can do that significantly simplifies the previous slide is, rather than doing all of this binding stuff in code, we could have the binding in the XAML, in that static text. And if we, left hand, right hand, left hand, right hand. And all we need to do if we're using XAML is create the data source from the namespace as we did before, set up our callback, but all the bindings are done inside the XAML. We can see in here we've got statements which say for the text box that's name is filter, it is bound to the thing called uppercase filter in the data source, which ultimately gets us to that variable in that namespace. And again, we can specify here that that binding works in both directions. So let me attempt to put some of that into action. So I'm going to start just a regular 14.0 interpreter, and if all is well, I can just sit here quite merrily hitting F12. Okay, we're already in a clear workspace, so I'm going to load a workspace that's got some samples in it. Oh, yeah. Enhance. Nice. There you go. Yeah, sorry, should have done that earlier. Okay, so big F12s. Okay, I'm just going to make sure that I've got an X drive mapped, because that's going to turn out to be useful later. I'm going to have a nice big quad PW. I'm just going to set up some quad usings and stuff. So these are the quad usings that I have in this workspace. Though all of you, no, that's not true. Sorry? Quad PW is the print width, is how much stuff I can display in the session before it starts wrapping. And it's useful sometimes that it's bigger than the session. So 2048 is over there somewhere. And then I get a horizontal scroll bar and stuff happens. We'll see that as we go through. Okay, so those of you that have used .NET programming and Dialog APL before will be familiar with quad using and will have seen some, all, or most of these elements before. But here's our dialog names. There are 19 of them. It is, at the moment, an incomplete list. So let me run through some of the contrasts that we have then between QuadWC and WPF and data binding. If we wanted to display this list of names in a list box in QuadWC, what we would do is we would create a form, we would create a list box, and we would just do an assignment to the items in the list box, and the names would magically appear in the list box. And that's all fine, and that's all cool. The problem now is if we want to modify the data, we want to add more names to the list. In QuadWC, it's always a two-stage process. We need to append a name to the vector of names. Okay, Nick is a recent addition to the team. But in order to get that name also in the list, we need to do the second stage. We need to also append Nick's name to the list of items that are in the list box. I mean, we could hide all of this stuff in cover functions, but generally, it's always a two-stage process. If we try and do the same thing with WPF with no data binding, okay, we create a window, we position it, we create a list box, we let me do these last two lines in a different order. Okay, so there's our WPF window with a list box in it. And to get all of those items in the list box in WPF, we need to add each of those items to the items collection of the list box, and we get the same stuff in the list box. But again, if we want to add a new employee to the list, it's a two-stage process. We need to first of all add it to the data array in the workspace. We need to add it to the list box. And this is where data binding sort of simplifies things a little bit. If we use a bound list for this, we create a window, we position it, we set its content to be a list box. Let me again do these things in the other order. Let's make that visible. But now with the item source, with data binding, we can say permanently, or at least for as long as both exist, or until we explicitly disassociate them, permanently associate the thing called dialog names with the contents of the list box. So we initially get the now 21 elements because we modified the global variable earlier. But now, when I make a modification to the names, because we've got that permanent association set up, they're bound might be a good word to use, I suppose. It's a one-shot deal. We update the data, and the user interface changes immediately, and it's up to date. And that's great for us as programmers. We can modify our data, and we don't need to worry about where this may or may not be displayed in the user interface. That was set up some time ago in the binding, either in the XAML or in whatever code actually created the user interface. So then I come along, I change my hat. I'm now a user interface programmer, and something has happened, and maybe I want to put a new item in that list. Okay, so as a UI programmer, I'd say, okay, just add whoever's missing now to the list of people that are in the list box. Okay, so the user interface side does that. Maybe our code gets a notification to say that that's happened, and we can deal with that. But now our names variable has automatically been updated with the modification that was made from the user interface side. Okay. So our two steps now have become one step for the user interface programmer and or one step for the data, the business logic guy. Okay, let me rewind those names back to the smaller set without everybody on. Now, data binding, or in fact, I mean, this 2015 IBeam actually is useful in contexts which maybe there isn't any GUI at all. For example, let me just illustrate this. So now I'm back to 19 names. Yes, I'm back to 19 names. Here is a snippet of C# code. And what we've got here is we've got a C# function that takes as an argument a thing called an iList. Okay, and what it does is it adds some elements to the list. It doesn't know what the list is, it just knows that it's got something called add in it that can take, in this case, strings that, well, something happens when you call that. So if we now compile that thing, what's happened? No, oh, it could be. Is it waiting for Notepad to go away? Oh, Guy. It's in and then out, isn't it? In, out, in, out. Okay. Thanks, Kai. I would have shut things down and it would have been more embarrassing. So, okay, so now we're going to extend our code using, so we're going to use the dynamic library that came from that C# code. Okay. And let's just look at dialog names again. Let's do... Okay, so our dialog names ends in Pete Donnelly and Jeff Streeter. If we run that expression and look at our names, now we see that our 4 names have been added at the end. So the I-beam not only gives us the facility to directly manipulate the APL arrays from the user interface elements, but because they implement this thing called iList, we can pass the result of the I-beam to anything that knows about lists, and it can enumerate through the list, do whatever it likes with the list, sort them, or even append items to them. And we would have got notification in the APL side every time one of those things happened. Okay. So now we've got lots of names. Okay, so now let's look at that user interface in its entirety that we talked about. Let me just trace through this guy. So here we have, I'm going to create a namespace called my source. I'm going to initialize filter, filtered list, and Dyalog names. I'm going to create a data source from that. I'm going to set up a callback, some code that gets called when any one of those elements changes, either because of an assignment in the code or because of changes in the user interface. And I'm now going to create some GUI, read the XAML that we looked at before, show the window, and set up the data context. Okay. So what this means is that if here's our element changed callback. So what we're saying here is if the name of the thing that's changed is filter, then what we're going to do is we're going to recalculate the value of the filtered list variable inside my source. And it takes whatever the current value of filter is and basically returns any elements of Dyalog names that include the text that we typed in the filter. Not the best APL code in the world. I'm not the best APL programmer in the world. Okay, but the key thing about this is there's no mention at all in here about the GUI. This is a namespace and these are variables. Okay, it doesn't care about the GUI. The GUI might not exist. The layout is unknown to it. All it's doing is manipulating the data. So if my source is namespace, look, it's got stuff in it. So if I modify the filter variable, okay, what happens is the data binding kicks in and our callback kicks in. The filter is bound to the text property of the edit field, which now becomes A. Okay. Our data source gets a callback to say filter's changed. Okay, we run that expression and we just modify the filtered list array, which is bound to the stuff that's on the right-hand side. And our user interface updates. It's a bit Harry Potter to say as if by magic, but it's, you know, without me really having to do anything. And in fact, I have to do so little. Wish I hadn't done that now. Yeah, all right, let me run that again. Okay, so, and as I say, the binding works then in a number of directions. If I type into the edit field, then the filter variable changes. Our callback runs again, and the list is updated. So I can type J-O. Well, that was a lowercase j, because it's not case sensitive. Uppercase J-O, return the Johns. J-O-H, return the Johns. D-A-I-N, return the Daintree. So it's just a very simple filtered list. And again, because that callback has got no concept of there being any user interface, I can run this thing again. Okay, but this time, not even bother creating the GUI. Okay, but I start off with an empty filter and an empty list. If I change the filter in code, then my list changes. Which means that because there's no reference to the GUI in the callback, I can write tests. I can say, if filter is John, let's make sure that the result, the filtered list, is what we expect. Okay, and then the other guys can create the GUI, and they can test in their own ways, however they want to, that their GUI works. But we can test our business logic without even having to worry about the GUI being in existence. Okay, we may have conditions where really the GUI is very important to us, but generally the core of the stuff we can test without worrying about any GUI at all. So what we had there then was we were data binding to a list of names. Okay. Something else we can do is we can data bind to a list of namespaces. If I create this names array, okay, which is a bunch of namespaces, each of which contain 4 fields: first name, full name, last name, and a field cryptically called photo. If we run the same, or at least very similar code, okay, what we're doing now is we're creating our my source namespace that contains filter and filtered list. But now our dialog names is, rather than being the vector of character vectors, is this vector of namespaces. Okay? Everything else is pretty much the same. I've just changed the callback a little bit because my data has changed, and therefore how I deal with it in the callback needs to be changed a little bit. We create this thing, and now what we see is in our list we see a bunch of things that say they are namespaces, but my filter still works. It just filters namespaces now rather than filtering on the strings. And what we can do is we can now modify the GUI. And if we go through, I'm going to now show this with a different version of the XAML, but notice that we're still calling input with binding 4. The same code is being run to set up the data and the data binding. So all I'm doing now is I'm wearing my GUI developer's hat, and I am playing around with the GUI. So the first thing I'll do is I'll say, OK, well, let's display the full names rather than the default display of the namespaces. And my filter still works. But on the right-hand side, I've said I want the right-hand side to only display the first name member of each of those namespaces. We can move further on. Again, more XAML, no changes to the code, just a GUI developer at this point. What I'm saying now is with my filter, I want to display multiple fields in each of the items in the list box on the right-hand side. So it looks like there are 1, 2, 3, 4, 5, 6, 7, 8, 18, 15 items there, but in fact there are only 1, 2, 3, 4, 5 of them, but each one is displaying multiple bits of information. We can take this one step further. The only difference now is rather than displaying the name of the file that contains the photo, we can get the WPF to show the photo for us. We haven't changed any code in the previous 4 or 5 examples. All we've done is change from a GUI programmer's perspective how the GUI is displayed. Our code has not changed. My callback on the filter is still doing exactly what it did before. It doesn't care that we're now showing photos rather than pieces of text. None of its business. All it needed to do was provide the information that that is where the photo is, and if you want to do something with it, it's entirely up to you. Okay, now I'm lucky. I have an example where all of my data is in vectors of namespaces, and if you're lucky, you'll get to see that in a moment. But that's not always the case. Sometimes your data might be in a matrix. Oh, let's get rid of that thing. Okay, so here we have a n by 4 matrix, full name, first name, last name, URL of the photo. Now, because our data is in a different form, we might need to modify our code a little bit. So we now have input with binding 5. And what input with binding 5 does is it's very similar to what we had before. We create a source namespace, we set up filter and filtered list. But now instead of using 2015 IBeam to associate with the dialog names array, or the dialog names namespace array, we're going to call a little utility function here, which creates a .NET thing called a data table, which is, if you like, a view on a matrix of data. And this is one of the areas where we will improve this in 14.1. This is where I am showing you stuff that doesn't work quite as slickly as it would be nice if it did. But what we can say is we're going to create a data table with 4 columns in it corresponding to the names in the data. 2010 IBeam is just a little optimization that we've had in Dyalog for a number of years now, which basically very quickly copies data from an APL array, in this case people, into a data table, in this case this thing called DT. Okay, and then we have some XAML that knows how to do things out of the data table, and we get a similar user interface. Now, the other thing that I've done here is because each row in the data table is essentially a single item that can be displayed on the right-hand side, it doesn't really make sense to have a filter on that. Well, it would make sense, except for the fact that the code in the callback would get very, very complicated. So I've taken that out for now, and I'm going to show it in a slightly different way. But in 14.1 or in 15, when we put the work in so that the 2015 data binding IBeam works on matrices, then again, all the complexities in your callbacks would just disappear, and you could just write general APL selection expressions on your matrix. So the way this works is I can just click on an item, and then I get in the right-hand side, at runtime, picked from that data table, the appropriate information for that. I was going to say employee, but I seem to have landed on an employer rather than an employee. But the point about this now is because everything is in the data table, okay, and we've bound the variables through the data table to the user interface, as I click through this, there is literally no APL code running anymore. Okay, we've set it all up and we've just fired it up and it's all running. There's no code in the interpreter, there's no code in the workspace to handle the selection changes. All of that was defined in the XAML to say that the content of this comes from whatever the selected item is on the left-hand side. And if anyone's interested in the XAML, they may or may not see that later in the morning, or you can come and talk to me and I'll fill in the XAML later. Let's look at more complicated data along the same lines. And I've tried very hard this year. Oh, no, this is cool as well. I was jumping ahead to the old stuff. Here is a text file that contains some XAML. Okay, this is a little hint as to where we might be going next. Okay, here's some XML. It is a list of disks. I don't know, they look like they might be CDs, I don't know. Each of them has got a title, and each of them has got a number of tracks which have got titles. Let's trace into this little example. What we're doing here is we're going to create some GUI using quad new, some WPF GUI quad new. We're going to create an XML document and get it to load its data from that file that I just showed you. And from that XML document, we're going to create a data provider, something that can be used as one of these data sources that we've been talking about. Okay. We're going to set that as the data context. The data that the entire form is going to use is coming out of that XML. I'll show that thing, then I'll move it out of the way so it's not quite as shown as it would be good. And then we set up some binding. Okay, we say for the first bit of binding, we're going to bind to elements called disk/artist in the XML. And we're going to associate that with the stuff in the first list box. The second list box is going to be associated with the title of every appropriate element inside that XML. And the third list box is a little bit tricky. It's going to be associated with the selected item in the parent node. Okay. Oh no, let me back up a little bit. There's two lines here. What it's saying is it's got two things. It says my source for my data is the albums element, which is the middle thing. Okay. But when it wants to display its data, it needs to get the selected item from its source, okay, which is, in this case, because we're just displaying the title, is just the title field. And the parent node then gets us from the title to the containing disk. Okay. So what happens then is what we see in the tracks thing is we end up seeing the content of the disk as we make the selection in the second box. All of this data is coming out of the XML file. Okay? It's not been loaded into an APL array. It's not in your workspace. As we do these selections, again, there is no APL code running. This is all being done now with data binding to stuff which is external to the workspace. Okay? But it's an example of another way of binding data from wherever it's come with your user interface. Okay, let's step back approximately 12 months and look at some stuff that I showed last year. What we're going to do is I'm going to load this workspace. Right, so what I'm going to do in here then is I have a vector of disks. There are 2,400 of them. Okay, they are all namespaces. The first disk has got a number of elements in that namespace. One of them is tracks, and it is a namespace, or it's a vector of namespaces, and each track has got a number of things in it. We've got a display form for each of our disks that the interpreter uses, so that when we look at it in the session, we get a nice picture. And what we've got here then is I've got some fairly convoluted XAML, which I actually went through in detail last year. If you were there last year, you may or may not remember it. If you don't remember it, you do remember it, or you just weren't there last year, it's on the YouTube videos thing. And what GUI nested does is it's sort of very much like what we've already looked at. It does a filter on disks, because I've decided in this example I only want to show those ones that don't have a default album cover, because that's fairly boring. We then create a data source from whatever disks we've selected. So disks is still a vector of namespaces, albeit somewhat smaller than the 2401. We're going to read some XAML. We're going to show the window that's the result. We're going to tell it that its data context is this vector of namespaces. And what we get is a user interface. What I'm using at the top here is a sync fusion control. It's called the carousel control. You could think of it as like a list box. It's a different way of showing a list of items. And the list of items that it is showing is each of the disks that were in that top level array. Okay. Now at the bottom here, we've got a list box. You remember where we had it with the XAML, with the XML case. We had a list box that was populated with the children, if you like, of the selection in the list that was to its left. And this is set up to do the same thing. The contents of this are obtained from whatever is selected up here. Currently, there is nothing selected up here. If I make a selection up here, then what appears down here is dug out through the data binding from the appropriate namespace that was in the code. And as I go through making new selections, then we get the new list of items. Okay. Again, once we set up the data binding, there's no APL code running at this point. There's no callbacks on anything. All it's doing is mining that data, because we've told it in the XAML, or we could have done it in the quad news if that's how we'd wanted to do it. We've told it how to mine through the data to display stuff. Again, not everybody has their data as arrays of namespaces. My data has been laid out like that for, I don't know, 10, 12 years maybe. So that's a natural way for me to do it. But what I've done here is I have folded that information now into a matrix, 2,401 rows, 4 columns. Sort of looks like that. Okay, the font's too big, but the first column is the artist name, second column is the album title, third column is a matrix containing the tracks information, which has got however many columns it's got, and the fourth column is the name of the JPEG, as it turns out, that is the cover of the album. And we can create a data table from that matrix and show it in a bog standard WPF grid. Not very interesting like that. But we can take the same data table and throw it at some XAML. Okay. Make a data table from the disks, throw it at some XAML, run the example, and it behaves in exactly the same way. So if your data is in a matrix, you can convert it into a data table and use that as a data source to your GUI as well. Again, no APL code running, it's all mining that data out of the data table. Oh, and don't forget, of course, this is two-way binding, okay? Still two-way binding. Let's look at the titles of the tracks in the 5th disk. Okay, I happen to know that it's this one. Come down here, click on this. I happen to know that the title of this thing's incorrect, so we'll fix that. We'll come back over here, and it's changed the title there of that first track. It was I'm running out of time. It's now changed to what I typed. Again, you get a notification that it's changed, and in future versions, again coming in 14.1, we hope to extend that so that not only do you get a notification that it's changed, but you get to format it, maybe uppercase it, maybe check that it's a valid string to go in whatever the appropriate field is. And do lots of other cool stuff that you obviously want to do rather than have people just arbitrarily manipulating your data from the user interface. And of course you can switch that two-way stuff off so your data is strictly read-only if that's how you want it. So I will finish off with Okay, so that's that. So I'll just finish off then with another example of a Sync Fusion thing. Get back in the room. Let's look at some charting. For some reason, these workspaces are taking a couple of moments to load. Here, it may be that the electricity near the sea is somewhat different to the electricity in Bramley. It may be that I'm actually suffering from the thing that Mark has been telling me he's been suffering from for a year, and I've never actually seen it, and now in front of 100 people I see it. But 2 minutes. 2 minutes. Okay, so again, we've got the same number of disks in here. Now, every disk has got a genre associated with it, and it's stored in each disk as a numeric entity. We have a variable containing what the names of those are, so we can dig out, for example, disk 1 its genre is progressive metal. I have a little utility function that uses Roger's fantastic key operator to sort my 2,401 disks into groups where they all have the same genre. So 15 genre disks just returns the 15 most popular groups. And we then have some XAML that displays a chart. And we have some code that, again, now this is exactly the sort of code you've seen before. We create some GUI. We create a data table from that matrix of music genres, which we make as the data context of our chart. Again, as of this point, there is no APL code running. Okay, this is a Sync Fusion pie chart thing, and the XAML has got all the bindings in place to tell it how to work. As we move around with our mouse, we get our tips. We can click on this thing and it pops out, and we can actually get a nice little 3D effect as well if we click and drag with the mouse. So the data binding gives us ways of associating with WPF controls that know how to display the data. Generally, and with more help from us as we go forward in 14.1 and 15, our data may be in many different forms, but we're working on whatever the form of your data is, getting it out to these .NET controls so that they can do a good job of displaying them. And obviously we've got, you know, the sharp plot stuff that Nick showed fantastically well yesterday. Nick and Getty showed well yesterday. This is just an alternative. If you want to live in the .NET world, then you may choose to use this stuff. Okay. But your takeaways from this, hopefully, are, and I've run out of time, some stuff you can do now with I-beams, and it's nice and quick and swish, you know, binding directly to vectors of vectors, binding to vectors of namespaces, for example. The I-beam's very good at that. We'll extend the I-beam so that if your data is in a matrix, we'll take away all of that stuff where you have to create the data tables yourself, which means we can be more efficient about it. We can do it sort of on demand. And then that will also enable the two-way editing of data back into your matrix, because the interpreter knows that there is this relationship. So I've got 10 seconds for questions. Failing that, I'll take them privately later.